Basic house construction. This chapter is basically a take-home chapter. It's only a couple of pages in your book, starting on page 179. It'll have some good pictures in it. Don't worry about the quality of the pictures. Just focus on what it is that you need to know. This should get you an easy 1 or 2 points on the exam. I wish it was more, but historically it's only 1 or 2. A couple of things you'll need to know as we're wading into this is that home construction is based on a North Carolina state law. What if you're in the state of North Carolina? So in other words, when you're getting building permits to build a home, you have to meet a North Carolina building code. I don't know if you remember in talking about that in an earlier chapter, but we talked about a building code, the state building code for building stick-built houses. And then if it was like a mobile home, that's a national, it's a HUD code. But anyway, building permits, they will be on a state and local basis for when building a home. Ultimately, your goal by getting all your inspections, getting all your work done, you'll get a CO, which stands for Certificate of Occupancy. And that gives someone the right to move into the home permanently, get permanent utilities and things like that. Again, just kind of FYI. Real quickly, general contractor license. If any questions come up at all about this, it may go something like this. For someone to build a house or to do an improvement on a property that is greater than $30,000, they would minimally have to have a general contractor's license to do that. So if you were to build a home and then try to sell it, unfortunately, if you didn't have a general contractor's license, you couldn't sell it immediately, but a GC would be able to do that, put it on the market and sell the property right away. In a previous chapter, we talked about the fact if you build a home and then live in it for a couple of years, build it yourself, contract it out yourself, you would be able to sell it then, but only after having lived in it for a certain period of time. GC, if the project's over $30,000, you must be licensed. A couple of quick architectural styles for you to take a look at. Not a big deal right now as we go through this. I'm going to start in the upper left-hand corner and I'm going to work clockwise just to name these styles for you. In the upper left-hand corner, you see a ranch. Now, don't let the dormers on the top of that house fool you. There's not a second floor there. That is a ranch that just happens to have dormers to allow more sunlight in. As you look on the right-hand side, directly adjacent to that, you'll see what's known as a Cape Cod. You can see that high sloping roof. Now, in that case, the dormers actually do go to a room. Some people will call this a story and a half. Because of the slope of that roof, you don't get a whole story up there, but you will be able to get about half story. Interestingly enough, with Cape Cods, some people will choose to finish the downstairs and then later, when they have more money, finish the upstairs. So that you would want to keep an eye on that in the field to see if it was finished at the same time or later with a permit. As you move down, you see a 2-story home. What's interesting about this 2-story home is there's part of this home that is above grade and part that is below grade. So you can see on the right-hand side, as you're facing this, you see 2 stories there downstairs and a upstairs on the property. And then when you look over to the left, you see that actually 1 story on the left-hand side where the garage is what we would refer to as below grade. On the right-hand side, we would call that above grade. You know, everything is actually built above grade, but on the left-hand side, below grade is defined by having any portion of the wall that actually touches earth. And you can see that that's the case on that because it's an odd-shaped lot. And then finally, in the lower left-hand corner, you see what we would refer to as row houses or townhouses. We talked about townhouses in a previous chapter about the legal aspect of owning a townhouse, what it meant from that standpoint. But from an architectural style, we often think in terms of a multi-story dwelling, attached properties. That's what we normally think about when we say townhouses from an architectural style. Recently, they've been asking questions, and one of the questions that come up on the test is, which of these homes cost the most to build per square foot? And the answer is simply, it's a 1-story ranch. And you say, well, why is that? Well, think about it. A 2-story house is just a box on top of another box. It's very, very efficient. It doesn't cover a large span of ground. But with the ranch, because it has such a large footprint, it takes more materials to build out a ranch. So if you see that come up on the test, which of these homes cost the most to build per square foot? It's going to be a ranch. Also, as we enter into the construction, what we're going to do is look at the way a house is formed. And so we're going to give you some structural components of that house. Over the next few slides, we're going to show you the most common foundations. This is what's known as a slab foundation. And when you look at that house, notice that basically what it is a concrete slab. That's going to be the base of the house, and the house would start building up from there. Let me give you something to compare to. My house just happens to be built on a crawl space. And you see the difference there. Instead of the house being being built directly on the ground on a concrete slab, it's actually raised off of the ground. And in fact, you can see that there's an area underneath that you could literally crawl under. If this were a larger crawl space, you might actually refer to it as a basement. Okay. Oftentimes in North Carolina, basement homes are put on odd shaped lots that fall off at the back, but a basement property is just simply a level of the house that is in fact below grade. So you can see there, the basement is pretty deep into the soil, and you can see the black mark there where they painted it to get it. It'll go actually down below the frost line. Fortunately, this is exactly what it looks like. When we talk about a vapor barrier, if you can't tell what that is a sheet of plastic that's laid on the ground. Below that is just going to be bare soil. And you can see in this case, they wrap the piers as well. We haven't introduced that word yet, but the piers are part of the foundation for holding up the house. And the idea of a vapor barrier, like I say, it's exactly what we said. It's to avoid moisture getting to the wooden structure of the house. So don't spend a ton of time thinking on that. It's fairly self-explanatory. Termite treatment is just an FYI. I don't see any red on here, so be familiar with this, but don't spend a ton of time studying this. In North Carolina, we get a question all the time. So, wow, do you really think we need to treat for termites? If you've not lived in North Carolina very long, absolutely we do. Why? Because we have dark, wet soils underneath the crawl spaces of houses oftentimes. So what happens when a new home is built, they actually treat the soil for termites before the house is built. After that period of time, it would be up to the homeowner to make sure that they maintain a termite policy, which I would highly recommend in North Carolina. Regular treatment for that, maybe even a termite bond that's transferable so that the new buyer would have peace of mind that you have kept it free from termites for that period of time. Okay. Now we're going to get into some actual parts of the house. And there's two things that I want you looking at here. One are the definitions of these words. And then the second thing I want you to look at are the way they go together. So notice how we start off this little section. We're talking about foundation components. So if you see a test question and it talks about which of the following would be part of a foundation, well, these words would go with that. They may throw in another word that does not go with the foundation, and that would be the essence of the question. So foundation components, we're going to have a footing, pier, girder, foundation, wall. Let's take a look at some of those words and see what they actually mean. The footing of your home is basically going to be a concrete trench that is poured, and it's going to be where the house is going to be built. So in other words, the footing is there for stability. It's going to stabilize the rest of the house. And if you'd like to have a little memory device for that, take a look at this. What's the base of your foundation? Well, it's your footing. Okay, so that's what the house sets on. It's a trench is dug and concrete is poured into that trench to serve as the base of that house. Now, on top of that footing, we're going to put a foundation wall around the exterior of the house. And you can see it's often a cement block piled on top of each other that creates a wall that is actually the start of the house moving upwards, foundation wall. Okay, the piers, it's hard to tell from this photo, right, here from this picture, but the piers are actually on the interior of the crawl space. So in other words, they're basically a foundation component, but when we talked about the footing being around the house and the foundation wall, the piers are actually on the inside of the foundation. And you say, well, what's their purpose? Well, hopefully you can tell from the picture here that oftentimes you have wooden components that run long spans. So what happens is the piers are put, I mean, you can picture in your mind, it's halfway in between the two exterior foundation walls. And so it's there to support. So when you see the pier, they're actually talking about that concrete structure that's built on its own specific footing, and it's there to support the middle of the house. It's inside the foundation wall. And when you look at a girder, again, I hope you can tell from the picture here that it's multiple 2x12s, it looks like in this particular case, that are put together. It looks like 3 of them that have been put together. Again, the girders sit on top of the piers, and their purpose is to support the floor joist in the middle of the house. Again, if you like memory devices, think in terms of a girder as being equal to a girdle. What's the purpose of a girdle? Well, it's basically to support the middle. So when we think about that, if it helps, fine. But that girder is multiple joists that are combined together to provide support on the middle of the house in the foundation. Okay, so now that we have our foundation set, we're going to start the wooden construction, the wooden, W-O-O-D-E-N construction of the house. So let's first of all take a look at that ground floor where we're going to start the upward portion of the house. Okay. Vocabulary word here. Notice that we have a little warning sign beside it. So you know that this is a word that often shows up on tests. This is the sill, S-I-L-L. Now you can notice that that sill is turned sideways. It's usually a 2x6 or something like that that's turned sideways that starts the upward building of the house. Sometimes you'll hear it referred to as the lowest wooden component of the house. It's a wooden 2x4, 2x6 turned sideways, and it starts the wooden construction of the house. Interestingly enough, the word sill also shows up when you're talking about a window sill as well. So just make sure you read the question closely enough. Are they talking about the one that sits on top of the foundation wall, or are they talking about one that sits in a window? If you know to look for it, it can't trick you. Not a big deal. Remember, we're talking flooring systems here. Okay, so we just started the upward building of the house as far as the wood components go. The next one are going to be your floor joist. And oftentimes your floor joist in general, are referred to as the horizontal framing members of the house. So when we're talking about a floor joist, you can see that it sits on the sill. It will run across the space of the house. Oftentimes there's going to be a pier and girders for the floor joist to sit on top of, and that's going to be where our floors are going to be built. You can see now that the subfloor is laid on top of the floor joist. The subfloor is typically going to be plywood or OSB. You can see it's usually like 4x8 sheets or something like that. And now we're setting those on top of the joist to create the subfloor. Obviously, the reason we're putting there is because ultimately you're going to put a finished flooring material on top of that. You're going to put something along the lines of a carpet or vinyl or hardwoods. And obviously, by laying the subfloor like this, there may be imperfections, but depending on the flooring type, if it's carpet, there would be a pad between the subfloor and the carpet. If you're doing some other type of hardwood floor or some other type of floor, there you might need leveling on that subfloor just to take care of any imperfections that show up in the wood there. Subfloor. Now we have our flooring systems in place. Here's another look at that, and to see how all this goes together. What you see there is you see the joist again, just from a different angle. They're horizontal. And then I don't know if you can see that perpendicular to the joist, you see what's known as a stud. And a lot of you have heard the word stud before. That's how we're going to build the walls of the house. And if you ever see the word stud show up on exam, they often refer to that as being the vertical framing members of the house. So you have your joists running horizontally, you have your studs that are going to run vertical to that to start the upward movement of the house. And then of course you see over in the corner of the baseboard, you often see the molding that's set down on the baseboard. The floorboards that are put down, they could be anything, could be vinyl, hardwood, et cetera, et cetera. And of course you see the foundation and sill plate. The sill sometimes referred to as a sill plate. Don't let that confuse you either, okay? All right, now that we're moving upwards, let's talk about the components that make up the wall and identify some of those. As we mentioned before, the studs are simply going to be the vertical components of building this house. We now need to start framing it up and that's going to create the walls. So a stud are the vertical framing members of the house. And again, it's usually something like a 2x4, and they're setting consistent distances apart depending on what the building code is and depending on whether they have to maintain a weight or not. The header, this is kind of interesting because you really can't see it very well from this picture, but typically the header acts kind of like a girder does. It's usually doubled up or a larger piece of wood that's designed to bear more weight. So you can see that that header right there is above a window. And the purpose of that is now that you're going to have weight from above, in other words, there could be another floor above this wall that you see here. So what the headers do is they take the weight that's coming from above and they disperse it out to the wood on the side. The reason for that is because there's probably going to be a window or a door there, and you don't want the weight to crush the less sturdy system, such as a window. So the header is going to sit above a window or a door, and it's going to be doubled up pieces of wood, lumber, or in fact, you can see in this case, it looks like it's probably a 2x10 or something like that. And what it does is it takes the stress and it spreads it to the outside. Notice the top plate in this case, it's exactly what it says it is. We are now finished with the first floor framing. So we put a top plate on the top of that to hold that together and to start the second floor if necessary. It is very descriptive of what it does, a top plate. You can see it looks like a piece of 2x4, just a second layer laid on top of the first floor framing. Okay, sheathing. Now look at your arrow there. And again, this is a little bit tricky, but what it's pointing to is the side of the house. I think of the sheathing as being the skin of the house. So you have all of your framing done, your studs are in, the whole house is framed up. Now what you're going to do is what the builder is going to do is come and put sheathing. And again, it's probably going to be plywood, or more than likely it's going to be OSB, which stands for oriented strand board. But that's going to form the skin of the house. Once you have the sheathing on, a house really starts to look like a house at that point. All it's lacking is siding and shingles at that point, and then it will really look like a house. So sheathing, the skin of the house. Okay, now that we have the house in play, let's take a look at the components of the roof and separate out these words. All right, when you're talking about trusses are interesting from a couple of standpoints. Trusses are a roofing structure, so let's start there. But they're a modular, they're an engineered roofing structure. If you've ever seen a truss, and I don't know if you can make it out in this case, but you see that there are a lot of angles that are being built. Now it forms a gable, but within that gable, there are a lot of angles. And what it's done is it's creating an engineered triangle. And actually triangles are one of the strongest engineering structures. And oftentimes what you'll see is you'll have plates, metal plates that are joining together at certain joints to create a very, very strong structure. These are pre-manufactured, and it's kind of fun when you're watching a house being built and they talk about swinging the trusses. That crane that they're showing right there, what they're doing is they're picking up those trusses off the ground, they're swinging them in place, they're putting them in place, and you can see that there's someone up on top of the on the roof there who's keeping them the appropriate distance and make sure that they stay in place. But it's at that point, you're now putting the roof on the house. Here's an interesting thing, and actually a testable thing to know about trusses. Because they are engineered structures, they allow you to have houses that are kind of free flowing. And what I mean by that is you don't have to have load bearing interior walls if you have trusses, because they bear the weight of the roofing structure. You don't need a load bearing wall to actually hold up the roofing structure. So trusses allow for interesting interior designs because you don't have to allow for load bearing walls. Now, when we're looking at this next section here, the particular board that they're showing is what's known as a ridge board or a ridge beam. Oftentimes you see these in rafters, which would be another way of building a roof. The rafters are less engineered. They tend to be individual boards that are put together. And you can see as these boards come up from the side that they meet at the top in what's known as a ridge board or a ridge beam. If I were to be tested on this, the question historically has been something like this. The highest wooden structure on a home is known as the what? Well, it's the ridge board, because you can see it's right at the peak of the roof in this particular case. So ridge board or ridge beam, the highest wooden component of the house. Now, when you take a look at the flashing here, I don't know if you can see, but basically what flashing does, that's where it's where an angle comes together. You see the two different roof structures coming together. Obviously, there's a punch out to the front, and then you have the main roof. Well, because of that, it actually creates an angle, and it also creates a place that would be easy for water to seep through, because you had to go and you had to make cuts there and things like that. So what the flashing does is put under the shingles, and it creates a barrier that's impervious to water at the place where two separate roofing structures meet, or two separate angles meet. That's what flashing does. And then if you look at this, you can see where the other penetrations are as well. You can see where the chimney goes through the roof. You can see where a vent comes up through the roof. All these penetrations will have flashing around them. What's the purpose of flashing? To keep water from getting into these crevices where these angles meet. All right, again, a little bit of a tough picture here. Fortunately, this is a word that many of you are familiar with. The word eave is just simply what a lot of people refer to as the overhang of the house. So you see the side wall there, and then of course you see that the eave actually hangs out beyond the overhang. The eave will have multiple components to it, but the overhang itself is what's referred to as the eave. Interestingly enough, there's a note here, 85% missed a question about what is below an eave. So we're going to show you what's below an eave here in the next couple of words. Okay, as we're looking at this overhang, as we're looking at this eave, notice that there's a board on the front. Notice it's turned sideways there. That's what's referred to as the fascia board. Think face, it faces the outside. It's a fascia board. And the purpose of that fascia board is to put your gutters. That's where you put your gutters. It does end the eave, but it's also a convenient place, excuse me, to hang your gutters as well. Let's continue to take a look at the eave and notice that there is also what's known as a soffit. Well, if you can see what that's pointed at, as the eave hangs over, there is an underside to that eave, and that is the soffit. That soffit is often perforated. And the reason it's perforated is it allows for air to flow through the attic. If you've ever been up in an attic, you know, of course, that that is one of the hottest places in the house, because as heat rises, it can get trapped if there are not ways for it to get out. And that's the purpose of the perforations in the soffit. Literally, that was one of my test questions 25 years ago when I took the state exam, was name the soft perforated underside of an eave. Soffit is what the answer was. And in this case, they're just showing you the tar paper that goes around the house. You can see that they're putting the tar paper onto the sheathing. In this case, it looks like the sheathing is in fact plywood, and that tar paper that they're putting on there, it is asphalt treated. And so it's not just a normal paper. It's trying to insulate the house to an extent, but also to make it impervious to water as they start to put the siding on. I told you on this test, they may in fact throw in some language having to do with components. So we looked at foundation components, we looked at flooring components, we looked at roofing components. Just to be aware of it, be familiar with some words that show up on window components. And listen, some of these words could just simply be almost like Sesame Street, which words belong to which component. Well, in the window components, you'll see things like, you'll see the sill down on the bottom. I caution you on that, but most of us are familiar with what a window sill is. You'll see the channel there is just simply where the window slides up and down. Sash is another word that occasionally will pop up for test purposes. The sashes are just the window portions that move up and down. And in this case, it's a double hung window. So both the lower sash and the upper sash can go up and down. There are a couple other unusual words that may pop up. The jamb, J-A-M-B, you'll see that word show up in components of not only doors, but also of windows. And the jamb is just where the window sits. The window unit sits within the jamb. Kind of rare that the words mullions and muntins would pop up. But if you ever see the word mullions and muntins, there's a good picture here of a muntin, but there's not of a mullion. You see it pointing to that. If you ever see a question about a muntin, it actually separates the window panes. Mullions, you often see if there are multiple windows side by side, it's the bar that separates actual windows, but the muntin separates the window panes. If I were going to concentrate on words on this, one, I would just recognize the words that go with a window, but the more important ones are going to be the window sill, the sash, understand the sash, the jamb, understand how that goes with the windows. You know, muntins and mullions, that's such a long shot. I don't even know if I'd spend much time studying those. Home insulation, just as an FYI here, you can see what this guy's doing is he's blowing in insulation. In the past, historically, we had bundles that we would just roll out in certain locations of the house. And when you talk about insulation, you'll hear people talk about an R factor or an R value. Well, here's what you need to remember about R value. It actually talks about resistance to elements is what it amounts to. The R values, they're going to be higher in colder climates. Why? Well, it makes sense, doesn't it, that you would want more resistance to the elements if you're going to be in colder climates. So you see that that's in red. That's a hint. But if that question does come up, insulation, R values, they should be higher in colder climates. Don't worry about trying to memorize what they are specifically for flooring or for walls or for ceilings. Don't worry about that. We'll let the contractors take care of that when they're building the house. How do we heat our homes? And you can see on one side the renewables. On the other side, you see the non-renewables. Natural gas is very common in our area for heating. Coal, less so, but possible. Fuel oil, until fairly recently, that had been popular as well. And obviously electrical is a way to heat homes as well. But here's what you want to watch for on the exam. Please be familiar that the most common method to heat our homes is what we call forced air. Now, keep in mind on the previous page, we talked about how we heat that air. But now what we're telling you is once the air is heated, it's going to be forced through a series of duct work by blowers. And that's how we're going to heat our house. So if you get a question about the most common method for heating our homes, there's going to be some fuel source, could be natural gas, could be oil, could be electric. But the way it's going to get through the house is through a forced air system. With that, we've touched on most of the words that you need for construction. So make a note of those, look closely in your textbook. I think it was on page 179. It's where that starts. And study. It's maybe an hour study total, but don't forget to study it because it could be worth as much as a couple of points on the exam. I consider them to be gimmies, and I want to make sure that you don't miss any of those. That is our basic construction chapter.